No, I'm just kidding. I'm kidding. The audio does work. What's going on, folks? How's it going with you? I don't know why we have like 3 people attending the class. Like, what's the deal, folks? In fact, I'm talking to you, people watching the YouTube video. You. I keep talking to like my picture, which is off, like the video, because I think the video camera's like right where the picture is, but the camera's right here. I'm talking to you. Where's everybody? Like Ted just showed up. So it's 9:30. Let's get this party started. I'll tell you what. I think what I'm going to do is I'm going to start using this thing called the quadratic equation, and then when more people get here, I'm going to prove it to you guys. I wanted to start with proving it to you, but there's no point in proving it to you because I proved it to you on Tuesday, and then I'm waiting for everyone to show up so I can prove it to you today. And if I prove it to you with 4 people instead of 5 people, and one of those 4 people have already seen it and actually enjoy it, like that, that proof and whatnot, is really hard. It's a difficult proof, and it took me an hour and a half just to get through it. And I did it in baby steps. So now you guys got to put on your big boy pants and just kind of. So, what did Calhoun say in Wreck-It Ralph? They're like, it's time to put on your big boy slacks. Nope, and no PP in the.
I haven't seen that.
Oh, you haven't seen Wreck-It Ralph?
No, I haven't seen it for a while.
Oh, it's a good movie, Wreck-It Ralph. All right. Anyway, let's do some examples. Let's start off with that. How's that? So turn to page I don't know. I think it's page 5. And it looks like they do example 1 for you completely. Why don't we do example 2? All right. Now, boys, who just showed up, let's start the class off like this. There's this equation that we called. All right. So.
Oh, you gotta tell them the story.
All right. I'll tell you the story. I'll tell you the story after I.
When you explain it.
After I explain it. Okay. So, we've been solving problems that look like that, right? We've been solving those kinds of problems, and those are called what kind of problems? They're not linear. They're called quadratics, right? And how do we identify a quadratic? This is like the first thing I ever taught you was how do you identify a quadratic? You can kind of tell because of that square term. That square term makes it a quadratic. If there is no square term, then it's not a quadratic. And the shape of that graph would be a line, most likely. You know what I mean? If that 3x squared wasn't there, then you have a negative 5x plus 1, and that's just a straight up line.
Yes.
Yeah, it'd be good for you to be here. Why would you not want to be here? No, we're not going to the exact same thing. We're doing a lot of different stuff. But I will prove. All right, so Brandy's saying, are we going exactly over what we went over on Tuesday? And the answer is absolutely not. But I will, at some point, when everyone else shows up, prove the quadratic equation again, because I really hate the concept of the 3 people who are new who just showed up here. Well, no, I mean they're different. They didn't come the last time. They haven't seen me prove the quadratic equation, and I hate to just kind of pull this equation out and say memorize this, but I'm waiting for everybody else to kind of show up and say, where are you guys and what's going on? All right. So anyway, what we've been solving is we've been solving these kinds of problems: the 3x squared minus 5x plus 1. The thing is, because there's an x squared term, we know that it's a quadratic, and we know that the shape of that graph looks like a what? Or is called a what? So it's with a P. You can say it. A parabola. Exactly. A parabola. And yeah, it's definitely some kind of virus. It's a parabola virus. And it kind of has this U-looking shape, right? Like the perfect way to describe it is to really just throw a ball up in the air and then have it come back down. See that shape right there that I make? That's a parabola. That is exactly a parabola. That actually kind of defines a parabola. In fact, the reason why we want to look at what a parabola is and we want to find out all of this information is because we want to solve stuff like this. And the world, a lot of the stuff in the world act like that. What are you guys listening to?
Mucus.
What?
Music.
No.
Very, very quietly.
No, you are not listening to music. No. Take out the headphones.
Brandy.
Not allowed. Not in my class. All right. Anyway,
I know.
there we go, Adriana. Thank you, Adriana. She just showed up. All right.
Hi,
Anyway.
Adriana.
All right. So check this out.
Brandy says hi, Adriana. Oh wait.
We've been going about this in two different ways. I've taught you two ways to solve quadratics.
Love you, Adriana.
The first way is I've taught you two ways to solve quadratics using this form. And by the way, I'm paying attention a lot to people online. That doesn't mean I'm going to burn these two students over here. What I mean by that is I'm not going to hold you accountable. I mean, I'm going to hold you guys accountable. But I want you guys to answer me online and whatnot. I don't ignore you and I don't forget you. The point that I'm trying to make is like when we have something in standard form, that thing, we've taught you two different ways to solve these problems. One is called factoring, and the factoring is where you put these two big parentheses, right? And then you break it up and you try plugging in a bunch of different numbers. And really, I think that the thing is, it's a game, right? It's this kind of thing where you just kind of like try out a bunch of numbers, and if it works, it works, and if it doesn't work, then move on to a different set of numbers, right? The problem is, it doesn't always work. And in fact, I'll tell you when it works. It works when your parabola falls perfectly on two nice numbers. Okay? That's when factoring works. It's when the x-intercepts are like pretty, like just whole numbers straight up. If they're whole numbers, then you could have solved it using factoring. If they're not whole numbers, then it would be really, really difficult to find it using factoring. It wouldn't be impossible, it'd just be really hard. And so the way we approach that is to say, okay, well, factoring is a really nice, quick, elegant way, but it doesn't solve every problem. Let me show you a technique that solves every problem. And the technique that solves every problem is this thing that we called completing the square. We spent 2 weeks talking about it. We spent more than 2 weeks, like 4 weeks, talking about how to complete the square. And that's like our bazooka. That one thing will shoot it down every single time. It will always work. Garance Bobarance, no questions. Okay? What I did yesterday was I showed you a third technique. And this third technique isn't actually even
The day before yesterday.
on Tuesday. When I showed you last class,
I did that too.
is
Wednesday, bro.
is
Wednesday.
when I showed you last class was this third technique. And this third technique is actually, it's not really even a third technique. It's actually doing the exact same thing as completing the square. You're just kind of doing it in one giant step. Does that make sense? Online, come on.
Did it get to?
All right. So here's what I need you guys to do. Write this down. 3x squared plus minus 5x plus 1. I'm sorry, Ted. I'm going to have to mute you. You're what? Huh? What's going on?
Wasn't finished printing.
I think he's talking to someone else. There we go. All right. So 3x squared minus 5x plus 1. Write that down. And what we're doing is we're comparing this to a very general standard form. And the general standard form that we're looking at is ax squared plus bx plus c equals 0. So that looks terrible. Let me write it. Let me kind of make it look a little prettier. That was ax squared plus bx plus c equals 0. Now, we know that x's are variables, but a and b and c are also variables. They can be any number you want them to be. They're still numbers. We just put a letter in there to represent, like, it can change that number. And in this particular case, if you compare a, b, and c to those, to the equation that you have in black, what is a? I want somebody online to answer this. Anyone online. Okay. John says 3x squared. That's not a. The 3 is the a. The x squared, see if I compare these two to each other, the x squared is still there. You see what I mean? But the number that a is 3. Exactly. So a is 3, b is negative 5. Exactly, Ted. You don't need to include the negative 5x because, we're just looking, The b represents what we call the coefficient. It's the number in front of the x. The a represents the coefficient, the number in front of the x squared. The c is all the other junk left over. Anything that doesn't have an x in it. Does that make sense? So the c in this case is 1. Are we cool with that?
Yes.
All right. Now, yesterday, or not, last class, I taught these two, because you guys weren't here, but these two,
Brandy and Diamond.
an equation that once you identify A, B, and C,
Details.
all you got to do is plug this into this equation. Do you guys remember this equation? It goes like this. X equals
A negative boy.
negative B. Do you remember?
Wait, yes I do. Was unsure
Plus or minus
if he was gonna go to a radical party or
square root
not. He ended up going, and he was a completed square or a square,
B squared
and he missed out on on meeting 4 awesome chicks.
4AC
And the party ended at 2 a.m.
2A. There we go.
Such a wonderful thing. I just can't.
You got it. Negative B plus or minus B squared minus 4AC all over 2A. So all you got to do is just take, okay, what is A? A is 3. What is B? B is negative 5. What is C? C is 1. And all you do is plug those numbers in. That's it. Plug it in, plug it in. I don't think that's Febreze. I think that's the, like it's,
Ted's just,
anyway.
he's just Ted.
All right.
The nicest way.
So the way you look at this is the negative B. What is negative B? What is negative 5? What is negative 5 is actually a secret code for
Positive dog.
5. There we go.
What? Did you just say? I did.
All right. What is negative 5 squared? Actually, you know what? Let's just skip what they're telling us. All right. So negative 5 is positive 5. Then I got my plus or minus, the square root of what is negative 5 squared? Positive 25. Got it? All right. Minus 4 times A times C. Look what A is, look what C is, and multiply that by 4. Multiply all that together. 4AC. What does that equal to?
12. Negative.
So it's minus 12.
Over.
All right.
6.
And then you divide that whole thing by 2 times A, which is 6.
Here, I have a question.
Yes, your question.
Never mind. Ignore that question. I
All
just saw it.
So, this is 5 plus or minus the square root of 13 divided by 6. That's what your answer is. That's literally, I mean, you stop there and you say, that's what my answer is. I mean, you could, if you wanted to, calculate out some numbers. In fact, let's do some Desmos work and see if that works. All right. First thing I'm going to do is, we don't know what square root of 13 is. It's not a pretty number. It's not like the square root of 16. That would be an easy number to take the square root of, right?
Google background makes me laugh.
The square root of 16 would be an easy number to take the square root of, right? Or the square root of 9. But 13 is not a nice number to take. But it is a number, right? There is definitely a number that the square root of 13 is. It's some kind of ugly decimal.
Google
fact-
it. When in doubt.
Square root of 13 is
Google it out.
3.60 blah, blah, blah.
3.61.
All right, 3.61. So all you do is you say, okay, well, what is 5 plus 3.61? I got to divide that whole thing by 6. So I'll just put divide 6. All right, so write this down for me. It's 1.43, it looks like.
1.43.
Or 1.44. All right, and then we'll put 5 minus 3.61, because it's both plus and minus. There's two answers, plus version and the minus version. So the other number I want you to write down is 2.31, or 0.2, or 0.23. Yeah, that'd be good enough. All right, then what we're going to do is I'm going to go over Desmos. All right, And then I'm going to graph this thing right here. 3x squared minus 5x plus 1. All right. Let's look at where it crosses.
Oh,
0.232, right? 1.43.
Oh, boom.
That's right. I picked up a pencil to
Girls,
drop
get on
it.
table.
Boot, bam. That's right, suckers. Look how cool that was. And obviously, this wouldn't have been able to be solved using, I mean, you can kind of tell that this wouldn't have been able to be solved using factoring. Because if it were able to be solved using factoring, then this number right here would be some kind of nice number. Like if it were the square root of 16, then that would just reduce down to 4, and then we would have known, hey, we could have probably solved that using factoring.
Yes, we can, John.
Yeah, but like
Yes, and in fact, all we're going to do today is we're going to prove, or we're going to show you how to use this equation. So I want you to I want you to memorize this equation, and I'll tell you what. Why don't I tell you the story about it now? I'll tell you the story on how to memorize it first, and then.
I said the
especially
story.
the story.
But
It's definitely said the story.
I said the
So,
story.
so I, well, they
Just
didn't
say it again.
they didn't hear the slow version, or they didn't hear the full version. All right. So I want you to write this down. Everyone, take out a piece of paper. X equals I'm serious. Like,
This is beast.
I got a question. When I tell you to write things down, do you guys actually do it? Or do you guys just kind of like,
Okay, I'm gonna be
Different.
honest.
Okay,
I'm gonna be
Mr.
honest.
Dalday. I'm
Sometimes
writing it down.
Okay, she's gonna be honest and say sometimes. I'm gonna be honest and say
No.
most likely not.
Yeah.
It's like, okay, Mr. Dalday. Uh-huh.
She's lying.
Uh-huh. Oh my gosh, Nicki Minaj. That's what you guys do at home. Yeah. Write this down. X
Oh,
equals,
crap.
hey, X equals negative B plus or minus. That's what the plus on top and the minus on the bottom means. The big square root, B squared minus 4AC, and put a big division sign under the whole thing and put 2A on the bottom. All over 2A. Okay? All right, that is called the quadratic equation. Now, let me tell you the story about how I memorized the quadratic equation.
I don't know how I memorized it, but I did.
All right, so
Okay.
the story goes like this. There was this dude. He was a boy. Sorry, it has to be a boy. He's kind of a negative guy, right? This negative boy, and
Technically, it doesn't have to be a boy, so
what is that?
it doesn't have to be a boy
Why doesn't it have to be a boy?
because
It has to be a
It
boy.
has to be a
'cause
boy.
It's B. Boy B.
Could have been girl talking
Okay,
to a
there's
girl,
this
Dad.
girl named Brandy.
Yeah.
All right.
That's right.
There's either a boy or a girl named Brandon.
My last name is Borges.
Okay,
so-
all right. So there's somebody who has a B associated with them. Please stop distracting me with that kind of stuff. All right, there's a boy, and he's kind of a negative guy, and he was invited to go to this party, and it was awesome. Well, he was, but see, the thing is, he was unsure whether or not he wanted to go to this party. Okay, but it was a radical party. It was like super radical. I don't know how to change that word. It was a radical party. Okay. And this boy was kind of a square. And I don't know if what does that mean to you guys? Like, does that like exist in your lingo nowadays, or just not?
A square?
Like we don't. Yeah.
Or red.
Do you ever call people like, "Oh, you're such a square"?
No. Unless their head
Stop
looks
being
like
such
square.
a square. You guys don't ever say that?
No.
All right, I just wonder. All right.
There's this guy that I know. His head is like in the shape of a square.
All right, fine. So
Just tease him,
So
call
he
him
was kind of a
SpongeBob.
square, right? And apparently, there's this guy that she knows that his head is in the shape of a square,
So we
which
call him SpongeBob.
which I would say isn't very attractive, right? Like
It's not.